Hello, everyone, and thank you for joining. Today's session, we'll talk about how to manage the open source components in your software with an emphasis on security vulnerabilities in the wake of recent shell shock story and in lieu of Heartbleed previously this year. We know that this is a hot topic right now, and many people developing software are very sensitive to this sort of vulnerabilities and are afraid that they may be impacted by them as well. My name is Rami. I'm the CEO of WhiteSource, and I'll be conducting today's session. Our agenda today would be firstly to discuss these vulnerabilities as well as to mention other vulnerabilities which can potentially infiltrate software via software development practices around open source adoption. We'll talk generally about managing security vulnerabilities with open source components, and then briefly discuss how WhiteSource service works and what it may contribute to development organizations, and then show you a quick demo of what the system actually looks like and how it does in fact detect the existence of shell shock and or Heartbleed in your own code. For administration, if you have any questions that you'd like to ask, please type them in the control bar and we will address them later. There are many of you, so we cannot open up the line and have everyone open access. So let's start with Heartbleed. Heartbleed was found earlier this year. It's a security vulnerability found in the OpenSSL component, which is, as you know, an open source component. It's arguably the most problematic or the worst vulnerability ever found in terms of its impact on the scope of its impact and the severity of the vulnerability and the amount of sensitive information that was exposed because of it. Many well-known and reputable companies were hit by it, and it was a huge, and still is a huge deal for security officers and generally software developers anywhere. Shell shock is more recent. It's just basically being found. It's a vulnerability with the bash open source component. It's similarly to Heartbleed, it's very, very widespread and it's very exploitable. There are already several known attacks that were conducted exploiting this vulnerability, but the full scale and reach of shell shock is yet to be unraveled. It's basically still an ongoing thing, and I guess it will take some time before we fully understand exactly what happened. Unfortunately, shell shock and Heartbleed are just the poster child for a wider issue that has to do with security vulnerabilities with open source projects and open source components. And there are, on average, several hundreds of security vulnerabilities in varying degrees of severity found in open source components each year. Most of them don't really make headlines and are not publicized in mainstream media. But if you are developing software, they may very well infiltrate into your products and end up exposing you and your business. The good news is that most open source projects, or at the very least the most popular, or the popular ones, the big ones, the well-maintained ones, have communities that maintain them, monitor them, look for these security vulnerabilities, and track and try to issue fixes and patches to the best of their abilities. But going back to your efforts, on average, an R&D organization consumes hundreds and hundreds of different open source components, and can't really keep track of all of them and monitor their respective community sites to see if vulnerabilities were discovered or fixed. Let's give you some numbers. A State of the Software Security Survey conducted by Veracode, released earlier this year, has indicated that 70% of software applications have security issues in a severity degree that is outside the range of the acceptable tolerance of the organizations that released that application. Open source, being source code or being software in its own right, is just as likely to have same security issues and other bugs. And when you adopt open source components that are vulnerable, you're basically opening your own product to these vulnerabilities. And to make matters worse, while still open source communities are doing very good job at tracking and fixing issues, there's generally a disconnect between that good work done in the community and the end user, namely the R&D teams, that can't realistically keep in touch and be aware that one, that even someone found the vulnerability, and two, that the vulnerability was fixed or that there's a newer version available to be patched. We've here on WhiteSource, we've run our own study. We've done some research on our own database that includes upwards of 3,000 real software projects from commercial organizations, and we found that 23% of said projects actually have security vulnerabilities, and oddly enough, only 1.3% of those of the infected libraries were latest version. So basically, in 98%, 98.7% of the time, the vulnerable library was an older version of the same library that's available potentially with a fix. So if the organization had been keeping its versions up to date, there's a good chance they would have been able to just patch the vulnerable library and not leave their software exposed. Now, the reason this is going on is that most of the focus that R&D teams dedicate to the security aspect of their software goes to their proprietary software, namely to the source code written by their own developers. However, in today's software economy, roughly 80% of any given software product is comprised of open source components. And as I said before, when an open source component that's embedded in your software is vulnerable, that makes your entire software vulnerable. So you can't really afford to keep ignoring the 80% chunk of your software that's not written by your own developers. And you have to start thinking about it in the same manner that you're thinking about the proprietary code that's written internally. So how are vulnerabilities discovered? Normally, being more popular than commercial software, open source components have a much wider spread of usage and therefore tend to be examined, even just by being used a lot, for security issues, and these issues tend to come up faster and more reliably than with commercial software projects. And there are reputable online public repositories that keep track of these vulnerabilities and report on them, and then even report when fixes are available, and try to mitigate this issue. Another thing to note about the open source nature of the vulnerabilities and the publicity that they get on these public repositories is that it's much easier for attackers to take advantage of them because they are well known, and because this information is publicly available. Hackers can get very easy access to exactly what the exploitability is for each library, and then take advantage of it. So why aren't R&D teams taking advantage of all this wonderful information and all the good work done by the open source communities? And there are several reasons. First and foremost is that most developers and most individuals on R&D teams generally aren't really aware that all of this is going on. They're going about their daily business, writing code, implementing more open source into their product, integrating it, and so on. Second reason is that these public repositories, while doing an important public service, are very difficult to work with. Their search capabilities aren't very advanced. It's not easy to determine what the full extent of the issue is. There's no way to see in a single place all of your relevant vulnerabilities and keep track on them and manage them, prioritize them, and so on. And there is no good way to match a vulnerability to a specific open source component, project, library, or otherwise. So it's a lot of manual work. It's very extensive effort to even try and understand which vulnerabilities are relevant to your project, your internal development project. And as a result of the lack of awareness, there's hardly ever anyone assigned to go out and look for vulnerabilities. And even if there is, it's a very tedious task of trying to search these public repositories. And then even if you find something, try to understand where it relates to your own use of that open source project and a relevant version, and where in your different products and projects would you find the infected library, and so on. So normally people don't do this, and they have no idea when a vulnerability is discovered. They don't know normally even the full extent of their own inventory, of their own open source library inventory, to even know what to look for in those repositories, and therefore are left without a good picture and without a good understanding of, one, what open source is being used in their software, is being embedded in their software, and two, the level of exposure or the level of security vulnerabilities that may exist in said components. We have some quotes here from analyst firms that reinforce everything I just told you. They speak to the disconnection between the good work done by the communities and the tracking repositories that are available, and the capability of the software development teams to take advantage of all of those good things, or lack thereof. Basically, there is no capability. So after trying to outline what the problem is and why it's essentially much larger than just the shell shock and Heartbleed that got featured in mainstream media and in top news, we'll try to demonstrate what can be done, how this issue can be handled, and essentially how you should do it automatically and not rely on resource-intensive manual efforts, which normally don't produce a very high-quality result. And this is where WhiteSource come in. WhiteSource is a very lightweight software as a service solution that manages your open source consumption for you. It can seamlessly integrate into your development environment, normally in the build phase. You plug it in once and then forget about it. The R&D guys don't need to worry about tracking or researching open source components. The system does everything for you and then alerts you on various types of issues that may arise from your open source, but more specifically about security vulnerabilities that are known to exist in the components that you've embedded in your software, and then going forward tracks additional vulnerabilities as they are found, and also tracks additional components as they are introduced by developers and can potentially have vulnerabilities. So since WhiteSource has a very extensive database of open source components, and when it is plugged into your build system, we can continuously monitor and always give you an up-to-date picture of what open source components are being used in your R&D, allow you to produce reports in any given point in time, and alert you on security vulnerabilities as they occur, and basically be very preemptive and preventative, and let you take care of these issues at a very early point in your development life cycle, where it's still cheap and easy to replace or to upgrade a library, rather than later in the process. For example, when you're doing penetration testing after code freeze and after QA and after the product has been finalized and so on, if you find an issue then, it's much more complicated and expensive to go back and try to fix it, change, remove the library, do all the coding around it, do another round of QA and so on. So how does it work? WhiteSource provides a wide range of out-of-box plugins to various build tools, all the popular ones, really. These then are triggered every time you run a build, or basically every time you decide you want them to be triggered. Could be nightly, weekly, continuously integrated on commit, so on. And when they are triggered, they would update the inventory of open source components that's being used by your developers, and then get all relevant metadata about those components and try to find security vulnerabilities for them. The service also maintains a current listing of all your open source components going forward. So if you've entered a component 6 months ago, but a vulnerability was only discovered last week, we would let you know about it. At this point in time, let's quickly skip to our system, and I'll show you a demo of what the system actually looks like. So keep in mind, again, this is a cloud-based software as a service solution, so everything is run from your browser. There's nothing to install aside from a one-time installation of a plugin to your build environment, and you're immediately good to go. What you're seeing right now is the main dashboard or the homepage of the service. That's generally divided into 3 parts. The top part is the alerts, which I'll get back to in a second. The middle part is a mini inventory broken into products. So for each of your products being developed, you can see the list of components with their license. And at the bottom are tickets for new libraries coming in. So whenever a developer adds a new library, firstly, the system will try to apply a pre-populated set of policies. And if none of the policies are relevant for said library, it would open a ticket and then start an approval workflow. Now for each library, we have all this metadata, including the identifiers, dependencies, known versions, older or newer versions than the one that you're using, links to the homepage and to bug repositories and so on. And you can even drill into the license and get some more information. This isn't a replacement for legal advice, but you can get some quick understanding of what's going on in that license and if it's good for you or not. Going back to the alerts, so once our system knows what the inventory is comprised of, it can start generating some insight into your inventory by producing alerts. So there are a few types of alerts: security vulnerabilities, which we will discuss in length in a second. And you can see others here, including new version alert that lets you know when a newer version is out to the market for libraries that you're using. There aren't any right now, but if you had policy violations, you'll see them here. If you were using different versions of the same library, that would also pop up an alert, so you will be able to synchronize the entire development team and make sure that everyone is using the same version so that there is less maintenance for you to do. And we also have a few other types of reports. The most basic one is a flat inventory listing all open source components with a short description for each, the license and its occurrences in various projects in your product or more than one product. And the nice thing here is that it takes maybe 10 minutes to set your plugin up and start updating your inventory, and you're already good to go, and you can export this inventory to an Excel spreadsheet and then share it with be it legal or security officer, compliance, or if you need to show this to a customer or a partner or during some larger transaction. It's very, very easy, very lightweight, takes minutes to set up, and take the entire R&D team out of the picture, let them go back to doing what they're good at, which is write more code and add more features to your product, while having a much better, higher quality understanding of what open source components are embedded in your software and what potential issues these components may have. Now, the other report I want to show is naturally the vulnerabilities report. This is a single report that shows you all of the vulnerable libraries that exist in all of your projects and products, and you can see all of them here in one place and sort them by severity even, and then you are able to prioritize how you want to tackle them, how you want to divide them between various development teams and so on. And you can, for each vulnerability, drill into its own page and get some more information, including the full disclosure data, the severity, the impact on your system. So the vulnerable library or libraries for this vulnerability may appear in more than one of your projects, and you can see references to potential fixes, workarounds, maybe new versions or patches that help you deal with this vulnerability, or just upgrade and close it altogether and move on to your next item of business. And we find that this basically saves you all of the effort of trying to keep track manually and gives a much better picture and a much higher quality result. And by actually giving you the full list of open source components being used in your software, which is otherwise very difficult to get, and the listing of all the known vulnerabilities for those components, which is, I would dare say, close to impossible to achieve with having someone try to manually research it online, try to look up vulnerabilities on public repositories and then match them to specific components that are being used by development. Now, going back to shell shock and Heartbleed, I want to show you what the process would look like to discover these vulnerabilities in your own, on your own development, in your own software. And for that purpose, I'll just go into an empty project here, which will simulate my development project. In this case, it will be a C++ project that I have some code for. For demo purposes, I'm using the drag and drop capability of our service, but in normal circumstances, what would happen is that these files would be synchronized using an agent or some plugin to your build environment, and this would be done continuously or on a nightly basis. Naturally, you wouldn't have to drag and drop all of your files or do it every time you change anything in your code. You plug in some agent and it will happen automatically. Just for the sake of the demonstration, I'm showing what it looks like from a drag and drop perspective. And now, after adding all of these files, the system then looks them up in our database and figures out. So basically, it ignores the proprietary code, the code that was written by our own developers. That part is never, ever exposed to our system. It only looks at the open source bits that they may have brought in by copying pieces of open source projects and then adding them to your own environment. And we can see that immediately our system identifies 1, 2, 3, 4, 5, 6, 7. So there are seven 7, sorry. Yep, components discovered here, and no big surprise that two of them is Bash and OpenSSL. And you can see in the alerts section that we are immediately notified that there are security vulnerabilities um, in our inventory, and these two security vulnerabilities actually relate to this one is Shell Shock, the GNU Bash 4.3, and this one is Heartbleed that has to do with SSL. So again, just let me run through the process here. What would happen is that you would connect an agent in your build environment. This agent would identify all of the open source components being brought in by developers and send that information over to our server. On our server, we'll do all the matching work with existing database and the database that we continuously maintain and add new information to, and then be able to display the list of open source components and then known vulnerabilities for those components. And these vulnerabilities may be Heartbleed and Shell Shock, and maybe other vulnerabilities as we've seen in the previous screens. But keep in mind, it takes 10 to 15 minutes, and you immediately are alerted to the fact that Shell Shock is hiding in your own development environment, and it lets you know exactly where, and allows you to then take action and remediate the issue very, very quickly and very early on in the development process. Okay, I think that's it for our demo. Let's go back and just sum up. So, everyone on the call knows already that open source is wonderful, but the great benefits that come with open source may be reduced by the existence of security and or quality issues with open source components, potentially risky licenses or compliance issues that are accompanied with open source components, and tedious manual management processes, research, and keeping track of open source usage by developers or by R&D teams. Whereas WhiteSource gives you an automated tool that takes minutes to set up, has zero overhead basically, and proactively manages open source usage, alerts you on issues before they become serious, lets you deal with them, and enforces your adoption policies for you, and takes care of all the reporting side and the auditing side for you, and lets you issue reports as needed, so you don't have to do any manual work yourself whatsoever. So it's basically a very fast, easy, effortless, cost-effective solution to manage your open source without bearing on your developers and without risking security or legal issues later on that may end up being business risks for you and your company. And with that, our time is up. I'd like to thank everyone for attending this session, and I hope to see you soon in one of our other activities or even talk to you in person.